Have you ever wondered why Pluto, once a planet in our solar system, was demoted to a dwarf planet? The answer lies deep within the cosmos, tangled in the intricate definitions that distinguish one celestial body from another. You see, when Pluto was first discovered in the early 20th century, specifically 1930, it was christened as the ninth planet in our solar system. An exciting discovery, a new member added to our cosmic family. But how exactly do we define a planet? Well, according to the International Astronomical Union, a planet is a celestial body that orbits the Sun, is spherical in shape, and has cleared its orbit of other debris. It's the third criterion that proved to be a stumbling block for our friend Pluto. Situated in the Kuiper Belt, a region beyond Neptune teeming with icy bodies and remnants from the solar system's formation, Pluto shares its orbit with these celestial leftovers. It's like a cosmic communal space where Pluto, despite its charm, couldn't quite assert its dominance. And then, there's the matter of size. Pluto is small, really small. With a diameter approximately 2/3 that of Earth's moon, it's a celestial shrimp in a cosmic sea filled with giants. In fact, it's so small that it's even outranked by several moons in our solar system. In light of these facts, in 2006, the International Astronomical Union made the decision to reclassify Pluto, no longer the ninth planet but a dwarf planet. A controversial decision that sparked debates among astronomers and the public alike. But don't let its small size or its demotion fool you. Pluto may be a dwarf planet, but it's a giant when it comes to enigma and mystery. Its icy surface, its moons, its atmosphere all hold secrets yet to be discovered. Pluto's demotion was just the beginning of the mysteries that surround this celestial body. So, buckle up as we delve deeper into the enigma that is Pluto, a cosmic underdog with a story that's anything but small. It took us 85 years after its discovery to get a close look at Pluto. What did we find? In the year 2006, NASA launched the New Horizons mission, a venture that would take nearly a decade to reach its destination. This mission wasn't just a casual trip around the solar system. Oh no, it was a daring expedition to the outermost reaches of our celestial neighborhood, to the icy dwarf planet known as Pluto. The journey was long and arduous, but on a chilly day in July 2015, New Horizons made its closest approach to Pluto, flying by at a mere 7,800 miles above the surface. This historic event opened a window to a world we had only seen as a blurry dot before. The data and high-resolution imagery New Horizons sent back to Earth were nothing short of groundbreaking. What we found was a world far more complex and geologically active than we had ever imagined. Against the backdrop of the inky black cosmos, Pluto emerged with a diverse and stunning landscape, etched with mountains, valleys, and plains. Some of these icy peaks tower as high as the Rocky Mountains, a testament to the surprising geological activity on this distant world. One of the most striking features revealed was a heart-shaped glacier, lovingly named Tombaugh Regio, after Clyde Tombaugh, the astronomer who discovered Pluto. This vast, bright, heart-shaped region captured our hearts and imaginations, symbolizing the affection we've come to feel for this distant, icy world. But these revelations were only the beginning. Each image, each piece of data, was a puzzle piece, bringing us closer to understanding the enigmatic world of Pluto. The more we discovered, the more questions arose. What powers this geological activity? How did these features form? And what does this tell us about other distant celestial bodies? New Horizons gave us a first tantalizing glimpse into Pluto's secrets. And as we continue to analyze the treasure trove of data, we look forward to uncovering more of Pluto's mysteries in the years to come. Did you know that Pluto is more than just a ball of ice and rock in the distant reaches of the solar system? Indeed, it's a world of unexpected complexity. When we first laid eyes on Pluto's surface, we discovered an incredible diversity of landscapes. From towering mountains of ice to deep winding canyons and vast plains of frozen nitrogen, Pluto is a geologically vibrant world that continues to astound us. One of the most remarkable discoveries about Pluto is its atmosphere. Yes, you heard it right. Pluto, despite its small size and frigid temperatures, has a thin but perceptible atmosphere. It's mostly composed of nitrogen, with traces of methane and carbon monoxide. What's more, Pluto even has weather patterns. It experiences seasons and has winds that shape its surface, creating dune-like features. And let's not forget about Pluto's moons. Pluto has 5 known moons, the largest of which is Charon. Almost half the size of Pluto itself, Charon presents its own set of intriguing features. The most striking of these is its reddish polar cap, a feature not seen anywhere else in the solar system. Scientists believe the red color comes from Pluto's atmosphere, where methane gas escapes and ends up on Charon, eventually transforming into a reddish organic substance. But perhaps the most exciting discovery of all is the possibility of an underground ocean on Pluto. You might be thinking, an ocean? On a dwarf planet nearly 40 times further from the Sun than Earth? It sounds outlandish, but evidence points to the possibility of a subsurface ocean of slushy water ice beneath Pluto's icy crust. If confirmed, this discovery could have profound implications, not just for Pluto, but for our understanding of where life could exist in the universe. Pluto, it turns out, is a surprisingly complex and active world. So, the next time you think of Pluto, remember it's not just a distant icy dwarf planet, it's a world full of surprises, waiting to be discovered. So, what's next for our exploration of Pluto, you might ask? Well, the journey has only just begun. The New Horizons mission, which in 2015 gave us our first close encounter with Pluto, continues to shape our understanding of this distant dwarf planet. While the spacecraft is no longer near Pluto, it continues to beam back data, a treasure trove of information waiting to be analyzed and interpreted. This data is akin to a time capsule, a snapshot of Pluto frozen in time. And with every byte of data we sift through, the enigmatic world of Pluto becomes a little less elusive. Yet, many questions remain unanswered. What is the composition of Pluto's surface? Our initial findings hint at a diverse landscape with vast plains of nitrogen ice, towering water ice mountains, and signs of past and possibly ongoing geologic activity. But there's so much more we don't know. And what of Pluto's thin blue atmosphere? Its existence was a surprise to many, and its nature remains a mystery. Composed mainly of nitrogen with traces of methane and carbon monoxide, it's a far cry from Earth's oxygen-rich air. But could it support some form of life? This question, perhaps the most tantalizing of all, is still up for debate. As we look to the future, proposals for new missions to Pluto have started to take shape. Imagine a spacecraft landing on that distant icy surface or a rover traversing its alien landscape. These are not just flights of fancy, but real possibilities being considered by scientists and engineers around the world. So, as we peer into the abyss of the unknown, we know that our journey to Pluto is far from over. The mysteries of this distant world continue to captivate us, driving our curiosity and our thirst for knowledge. The exploration of Pluto has just begun, and there are many more secrets waiting to be discovered. Why does Pluto continue to captivate us? This tiny celestial body, often the subject of schoolyard debates, has held our collective fascination for almost a century. But what is it about Pluto that keeps us so intrigued? Perhaps it's the allure of the unknown, the thrill of discovery. Despite being discovered over 80 years ago, Pluto has managed to keep many of its secrets hidden. Each new revelation about its composition, atmosphere, and moons only serves to deepen the intrigue. Scientists are still unearthing new knowledge from the data collected by the New Horizons mission, making Pluto a continued source of scientific discovery. Or maybe it's the way Pluto has wormed its way into our cultural consciousness. From Mickey Mouse's faithful canine companion to the Roman god of the underworld, Pluto's name alone carries a certain weight. Its story, too, has a certain drama to it. The saga of its discovery, its decades-long tenure as the ninth planet, and its controversial demotion, all play out like a space opera on a cosmic scale. It could also be the sense of nostalgia that Pluto invokes. For many, Pluto was a cornerstone of our childhood understanding of the solar system. Its demotion to a dwarf planet may have been met with resistance, but it also served to rekindle our fascination. It reminded us of the ever-evolving nature of scientific knowledge, and that there is always more to learn, more to discover. Ultimately, Pluto's allure is a combination of all these factors. It's a symbol of our insatiable curiosity, our drive to explore, to understand the universe around us. It's a testament to our capacity for wonder and the joy of discovery. From its discovery to its reclassification to the ongoing exploration, Pluto continues to remind us of the wonders and mysteries of our solar system. And as we continue to delve into the depths of the cosmos, Pluto will no doubt remain a source of fascination, a celestial enigma that continues to captivate us.